All right, well, now we're looking at solving systems of equations in three variables. And over on page 162 in example 1 and guided practice 1A, we see these three equations that I've got written down. So I got 2x plus 4y minus 5z equals 18. Second equation was negative 3x plus 5y plus 2z equals negative 27. And the third equation is negative 5x plus 3y minus z equals negative 17. And you can see over here I labeled these equations A, B, C because one of the more difficult things about this, and if it's not difficult enough, is I've got to keep a certain amount of organization going or I'm going to get totally lost. And you'll see why here as we go along. So my first task here is I want to get this from a 3-variable equation to a 2-variable equation, or equations I should say, so that I can begin to start finding some values for the variables. Now, how I approach this and how you approach this could be somewhat different. This is not a rote memory way to go about doing things, except that in terms of the certain steps. So the way I'm approaching this problem at this point, I'm looking at these equations B and C, because I see I got negative 3x plus 5y plus 2z equals negative 27. And then I've got in the C equation, it's negative 5x plus 3y minus z. And I see that if I multiply the C equation by 2, I'd have a situation where I'd have positive 2z and negative 2z, and I could eliminate the z variable. So I'm first going to put B and C in the game. Now again, you don't have to approach this the same way. You could look at these same three equations and start eliminating in a different manner, but again, the first steps I'm trying to get to is get these equations to where I can have them in 2 variables. So let's see, let's take this C equation and I'm going to multiply, and I'm going to put up here, I'm going to say BC. So I'm dealing with B and C, and I'm going to take this C equation and I'm going to multiply it by 2. So I got 2 times negative 5x plus 3y minus minus z first equals negative 17. I'm multiplying the entire equation by 2. And when I do, that's going to give me negative 10x plus 20y minus 2z. That's a nasty looking z. Let me see if I can erase that. 2z equals negative 34. Now, I'm going to pull down equation B, and we're going to add those two together. All right, so if I pull down B down to here, so then I've got 3x, or negative 3x, plus 5y, plus 2z equals negative 27. And I'm just going to add those together. And that's going to give me negative 13x plus 25y, and my negative 2z and my positive 2z are going to cancel, and that now equals negative 61. All right, now I've got to get the A equation into the game. So I'm looking here, 2x plus 4y minus 5z. Again, I'm wanting to eliminate the z temporarily, and I need to choose either B or C to do that. And when I work this problem, for whatever reason, I chose to use A and B to do that. I could have used A and C, but I got to get A in the game. So let's see. I'm going to go up here. I'll maybe put it in a different color. And so AB. All right, so I've got 2x plus 4y minus 5z equals 18. And B is negative 3x plus 5y plus 2z equals negative 27. All right, so now if I multiply the A equation by 2 and the B equation by 5, I'd end up with negative 10z and positive 10z. So I could eliminate the z. So let's go about doing that. So I'm going to multiply this top equation, this A equation, by 2. And I'm going to multiply the second equation by 5. Let's bring this down here. And making these little notes and arrows, that can help me keep things straight. What did I do? So let's see, that would give me 4x plus 8y minus 10z equals 36. 2 times 18 is 36. And let's see, I'm going to take this next one, bring it here. And so then that gives me negative 15x plus 25y plus 10z. And that equals negative 135. Let's add those two equations together. And I should have my z's eliminated. So let's see. I guess that's negative 15x right there. Negative 15x. All right, so that gives me negative 11x plus 25y. No, 33y. 33y. It's easy to make mistakes on these. Negative 11x plus 33y equals negative 99. Okay. Now, I can take this equation and this equation and solve those two systems, and where I can find values for x and y. And let's see, I wonder if I got enough room here on this. Well, I think I got enough room to find that maybe one of the variables. No, I think I'll go to another slide. Okay, so I brought over the two equations that I was left with after eliminating the z variable. Remember, I used B and C to come up with this equation of negative 13x plus 11y equals negative 61. I eliminated the z variable there. And then I used A and B, the A and B equations, to come up with ended up with a negative 11x plus 33y equals negative 99. And now I'm going to eliminate either one of the x or the y variables. And so my approach, and again, you could approach this differently, but you still got to use the same concept. I want to eliminate one of the y variables. And let's see, I think if I were to multiply this first equation by negative 3, when I say the first equation is negative 13x plus 11y equals negative 61, I'd at least end up with a negative 33y, and then my second equation would be a positive 33y. So let's go about doing that. So I'm going to take negative 3 times negative 13x plus 11y equals negative 61, and I'm multiplying that entire equation by negative 3. Now that's going to give me 39x plus negative 33y equals, let's see, negative 3 times negative 61 is 183. Now I'm pulling down the second equation here so I can eliminate that y. And that was negative 11x plus 33y equals negative 99. Okay, yeah, that looks right. Now I'm going to add those two together to eliminate this y value, and I'm going to solve it for x. So let's see, 39x minus 11x gives me 28x. This is going to cancel. And let's see, 183 minus 99 is 84. I'm going to divide both sides by 28, and x is equal to 3. All right, so I believe x is equal to 3. And typically, you're going to get an integer. If you get something that's not an integer, some kind of fraction, some kind of decimal, it's probably something going wrong. Now, I'm going to substitute x into this equation right here. And I want to choose it because I didn't do anything to that equation, at least on this, once I got to this point. So let's plug in x for here and see if we can't find a value for y. So I've got negative 11 times 3 plus 33y equals negative 99. Remember, I'm using that equation right there. So I got negative 33 plus 33y equals negative 99. And we're going to add 33 to both sides. That's going to give me with 33y equals negative 66. And when we divide both sides by 33, I've got y is equal to negative 2. All right, so I think I've got a solution for at least two of the variables. And let's see if we can't go over here then and solve for z. And hey, I may end up having my my ordered triple that I'm looking for. I ordered triple and solving equations with 3 variables. All right, so I've brought over our 3 original equations and also what we think our values for x and y are. And we're going to substitute those two in to one of these equations and see if we can't find a value for z. At least we're going to, and then we're going to double check it. So let's see, I'm going to choose this top equation right here. So I got 2 times 3, I'm substituting in 3 for x, plus 4 times negative 2 minus 5z equals 18. All right, well, 2 times 3 is 6, and 4 times negative 2 is negative 8, minus 5z equals 18. All right, so 6 minus 8 is going to be, gets negative 2 minus 5z equals 18. Let's add 2 to both sides. I got negative 5z equals 20. And divide by negative 5. And so z, I'm thinking now is negative 4. So I think my solution there is negative 4. So 3, negative 2, negative 4, my ordered triple. Now I'm going to take and check my work because I'm going to plug in all 3 of those values for x, y, and z into one of these 2 remaining equations and see if I can solve that to a true statement. So I think I'm going to choose what we had previously labeled as equation C. No special reason. I could have picked B. I just don't want to use A because I used A to find Z. So let's see. I got negative 5 times 3 plus 3 times negative 2. I'm substituting in these values for x, y, and z. Minus negative 4. Putting in negative 4 for z. That's going to make that plus 4. equals negative 17. All right, so negative 5 times 3 is negative 15. And 3 times negative 2 is negative 6. Plus 4 equals negative 17. And negative 15 and negative 6, let's say that's negative 21 plus 4 equals negative 17. And you can see that negative 21 plus 4 is negative 17, does now equal negative 17. And Shazam, I have found my ordered triple. X is 3, Y is negative 2, and Z is negative 4. Now, that is amazing.